All right, it's acids and bases time, but right now we're up with Arrhenius theory. So let's talk about a hydrogen ion. All right, so let me just grab my pen for a moment here. So hydrogen, right here, has an atomic number of 1. That would be here. Also mass number of 1. So to find the number of neutrons, I would subtract those numbers. You could see it's 0. So what that means is since the atomic number is 1, hydrogen has 1 proton, right? Since it has 0 neutrons, the proton is literally the only thing inside the nucleus, okay? But remember, protons are positive and an atom is neutral. So if it has a positive, it has to have a negative, and that negative comes from an electron. So a hydrogen atom with 1 singular proton and 1 singular electron. Now what happens when it loses that electron? Right? So it loses that electron. It becomes a hydrogen ion. That's H+. That's what happens every time something loses a negative. It loses an electron, it becomes a positive. But now look, this electron is gone now, so the only thing that is left is a proton. So a hydrogen ion, after it loses an electron and becomes H+, is literally the same exact thing as a proton because that's all there is. That's all it is. So a proton is a hydrogen ion. So H+, a hydrogen atom that has lost an electron, is the same exact thing as a proton. This is going to become important later on when we do some more acid-base theory, but it's better to introduce it now. Okay, so a hydrogen ion, H+, and a proton are the same thing. Okay? So hydrogen ions, they don't like to be alone. Kind of maybe insecure, lonely. So when they're around water, they find water and attach to it. So hydrogen ions right here don't like to be alone. They find a water molecule and attach. So this is H3O+. It's a hydrogen ion with a water molecule, and it is called hydronium ion, okay? So in reality, we could say that H+ and H3O+ are essentially the same thing because barely ever will you find H+ by itself. It's going to find water and stick to it. And then we have hydroxide ion. All right, hydroxide ion is OH negative. Now, something important you could notice here is that water split apart is H+, one of those H's, OH negative, the other H plus the O. So when a water is broken apart, we get H pluses and OH negatives. All right, let's talk about acids for a minute. They taste sour, they're electrolytes, they're conductors, they react with a lot of metals, which we'll get into greater detail in the next unit. We can find them on table K. Remember the stronger ones at the top. So strong ones up here, weak ones down here, which makes sense because this carbonic acid is from soda, and that would not make sense for it to be a strong acid. Okay, so the strong ones at the top, the weak ones at the bottom. And what about properties of bases? Well, they're bitter, they're slippery, they're also electrolytes and conductors. We can find their information on table L. So the strong conductors, the strong electrolytes at the top, the weak at the bottom. In reality, this is the weak one in this table. The rest are strong. And you can see a pattern. They all have OHs, except for this kind of oddball. All right, there are two acid-base theories. There's the Bronsted-Lowry theory and the Arrhenius theory. Today, we're going to focus on the Arrhenius theory. So what is kind of that overwhelming difference between them? Well, Bronsted-Lowry talks about protons. Arrhenius theory talks about H pluses and OH negatives. All right, again, here's another summary of both theories. Remember that H3O plus is hydronium. It forms because H plus is going to stick to a water molecule. Okay, so again, this is just an overview. Let's talk about it. So today's lesson, we're going to focus on Arrhenius theory. So let's learn. So we have an Arrhenius acid. What is that? Well, when you take an Arrhenius acid and you put it in water, so you put it in an aqueous solution, what you're going to see is H plus as the only positive ion in solution. That's the definition of an Arrhenius acid. It has H pluses as the only positive ion in solution. So you mix it with water and you get H pluses as the only positive ion. So Arrhenius acid, you could tell most of the time you're going to see it start with the letter H. We get H pluses over here. That's how I can tell it's an Arrhenius acid. I get H pluses as the only positive ion in solution. So what about an Arrhenius base? Well, when you take an Arrhenius base and you put it in water, you make an aqueous solution, you get OH negatives as the only negative ion in solution. So let's look at a whole bunch of them. Look on this side. What's the only negative ion you see? OH negative, OH negative. Okay, so when you take an Arrhenius base and you make an aqueous solution, so you add it to water, you're going to get OH negative as the only negative ion in the solution. So Arrhenius acid gives away H pluses, Arrhenius base gives away OH negatives. Okay, so Arrhenius acids, H plus, the only positive ion. Arrhenius base, OH negative, the only negative ion. So when we look at equations, so an Arrhenius acid produces H pluses. It also can be written, remember, as H3O plus because H plus sticks to water. All right, so here, this, at first you would say, oh, I don't think it's an Arrhenius acid. But look here, you see this H3O plus. Anytime you see H3O plus, think H plus. Okay, so this is an Arrhenius acid because I see H plus or H3O plus as the only positive ion. Arrhenius base, OH negative as the only negative ion. And there you go. That's Arrhenius theory. So I hope that you learned something new today.